Okay, so today we'll start off with our CTF journey under cryptography using sokonalysis, which is the Cipher toolkit built for skill levels. Okay, so basically you can install this particular tool in Windows by following these steps. Then you can also do the same in Linux by following these steps. So everything is just simple, you just copy and paste until you have the tool built up. Okay, so the first thing, for the first time use, you'll be prompted with the agreement terms. Okay, so we are saying this tool is for educational and ethical use only. Do not use this software for any malicious, unauthorized or illegal purposes. So if you agree to these terms, just say yes. So if you don't, we all know you won't use the tool, but anyway, we just agree. Yeah, so this is the tool menu. So basically this tool is divided into 3 parts. Okay, so the first part is the university level, where we'll be helping out our university students to actually understand basic cryptographic algorithms and how to do these things more practically and confirm the answers when it comes to exams, assignments or other related tasks which they might be given. Alright, so the next phase is what we are calling the CTF level. Basically this is meant with a purpose to say, instead of you utilizing a lot of resources online to solve one cryptographic challenge, you just utilize one basic tool to actually solve that particular question or challenge until you get your flag. Okay, so this is an example for RSA under Pico CTF, which is demonstrated there. Then so far, the last level or the phase is called the advanced level for enterprises, organizations, but we haven't yet started implementing this one. So updates will be made as we go on. So these are the current supported algorithms. So in case you want a copy of this particular tool, because right now it's a private repository, you can just submit your GitHub username or email for you to get a copy or to start using this particular tool. Okay, so the challenge we are doing today is called Feed Me Seed. Okay, so only 203 people tried to solve this challenge and failed, but only 36 were successful. Okay, so it's rated as easy because it's 50 points. So we are saying my new parrot needs some seed. I heard that you have some seed. Can you give me some seed? Okay, so we are using parrot OS. Maybe you already have the seed, but we don't know. So we try to download this particular zip file we are given. So it's saved under crypto here. So in your case, it will be saved whatever you want. So we say extract here. So the first step, we are going to analyze this particular Python code or script you are given. So we are using AS, then we've imported pad, which will be padding something, and the random to randomly generate something. Okay, so the seed which we are given, or let's just say a random number, is 1 up to 6. Then we have a key which are using random bytes, which is starting at 16. Okay, so take note of this. This message is 14 bytes. Okay, then this message which is being padded, we are simply adding 2 bytes in AS using the ECB mode. So if we say 2 plus 14, we are getting 16 in the first round. So it means this message which is being encrypted is just encrypted within the first round. So it's more like we're encrypting this flag. Okay, so for us to understand this, we can actually try it out here. So we are going to say Python 3, the name of the script. So you can see we have something which looks like a binary, more like raw data, but for us to get results in hexadecimal, we can just say dot, then hex for hexadecimal, like that, then we save it. So if I run this particular code again, we are going to see that okay, now the result is in hexadecimal. So because the result is in hexadecimal, we can now run our two sokonalysis to actually see if we can decode that one. So remember, that's just the first round. So I'll agree to the terms, and then option number 6 is now capture the flag, which we are playing. Then we have this option, which is AS, Advanced Encryption Standard, as option 9. Then the first option, which is just the only option right now, is the weak key derivation attack. Okay, so if I paste the hexadecimal, which I've just obtained there, we can see that we're getting a flag which is redacted. Okay, so if I come to my submissions here and CyberTalents, we just want to see something. So if we come to the submission, that flag, this flag which you are seeing right now, which is called flag redacted, you might think okay, it's the correct flag because you are praying. Okay, but if you see, this flag called redacted is actually wrong flag. Okay, so because it's a wrong flag, it means that maybe you've just obtained the wrong flag. But remember at first what I've said, this flag we were already given. Okay, so they cannot actually give you the flag in the actual sense. So it's more like they're just simply telling us, say, this flag you have obtained or you already know is being encrypted in the first round. Okay, and that message is what we are obtaining here. Okay, by printing the encrypted message. That was the meaning. Now here we can see we have a comment, and when it comes to CTF, each and every particular thing, actually we need to pay attention, even though it's a comment, but this seems like a raw data for which we can actually try to convert into hexadecimal for us to now actually try to retrieve if it has the correct flag. Okay, so we are going to utilize the same method, but I want to modify their code, but we are just going to use Python directly to convert this particular raw binary data into hexadecimal. So what we do, we say Python. So if we are using Python 3, I'll just say Python 3. Then if we press enter, so take note to now this particular raw data starting is supposed to have a B, then open and close single quote. Then for us to decrypt, if we follow this step which I said, we said hex for exam, then we actually open up the brackets and close them for us to get the hexadecimal value. So this is what you're doing, but in between we need to paste that particular data we are given. So including the equal sign, yes, we want that because only the hashtag was the comment. So once we press enter, we can see that we've actually converted that raw binary data into this particular hexadecimal value. So just like we did at first, I'll copy that, then we are going to just say yes or continue with this particular two. Okay, so now I'll go back to AS, which was option number 9. So I'll paste this particular hexadecimal data. Then we can see now we've got our flag, which is exposed seed is not good seed. Okay, so if we come back to our submissions, we are going to see that actually this particular flag is the correct flag. Okay, so as I've said, all the links including for the two will be available in the description if you want a copy. So you can do as wise by dropping your username or email. I'm sure I'll even post a particular form to do that. So all the best in solving this particular challenge. See you in the next one. So by the way, my name is Asoko James. So the developer for sokonalysis, which is the Cipher Toolkit built for all skill levels, and the tutor from the KMU Cybersecurity Tutorials.